Hello everyone. So for our session today, we will talk about polynomials. So here are our objectives. We will differentiate a polynomial from an algebraic expression and classify algebraic expressions which are polynomials according to number of terms. So let's try to consider the following examples and non-examples of polynomials. I will give you time to observe. So please pause this video and try to differentiate the two based from the examples and non-examples. Okay, so let's check if you can now identify a polynomial from a non-polynomial. So here's our instruction. Let's try to connect our previous lesson from our current lesson. So let's identify first if it's an algebraic expression or not. And then the second one would be polynomial or not. Number one, 3a. Yes, the answer is it is an algebraic expression. At the same time, it's a polynomial. Let's have number two. Negative 4x cubed y to the power of 7. Yes, that's correct. Algebraic expression, and it is a polynomial as well. Let's have number three. 2 over x. Yes, it's an algebraic expression, but it is not a polynomial. Let's have number 4. Square root of 3, x to the power of 5. So the ones with the square root is just the 3, okay? Not including the x. Okay, that's correct. It's an algebraic expression. At the same time, it's a polynomial. Again, I will not explain it yet. I will explain later. For now, try to check whether you can already identify whether it's a polynomial or not. And of course, if it is an algebraic expression or not. Okay, number 5. Square root of x. Okay, correct. It's an algebraic expression, but it is not a polynomial. Let's have number 6. 9x to the power of negative 3. It is an algebraic expression, but not a polynomial. Okay, let's have number 7. 5 square root of 3x. So this time, the x is already inside the square root. Correct. Algebraic expression, but not a polynomial. So very good. So let's try to summarize all of our answers. So numbers 1 to 7, they're all algebraic expression, but not all of it are polynomials. So only 1, 2, and 4 are polynomials. So my question now is, what is a polynomial? Okay, that's correct. We answered all of them as algebraic expression, but not all of it are polynomials. Because polynomial is at the first place an expression, but it is a special kind of it. So what makes it special compared to other algebraic expressions? Still, each term has a constant, has a variable, and perhaps it can just be a product of a constant and a variable. So meaning just one term. But the variables should be raised to a positive whole number exponents. So how will we make things easy? So remember, it's an algebraic expression all the time. But not all of the algebraic expressions are polynomial. But all polynomials are algebraic expressions. So take note, still it has a constant, a variable, and a product of constant and variables, but it has to be raised to a positive whole number exponents. So How can we easily determine whether it's a polynomial or not? So first, let's check number 3. So 2 over x. It's not a polynomial because the variable is in the denominator. So if the variable is in the denominator, then it is not a polynomial. Okay. How about 5 and 7? So why is it that the following are not a polynomial? Because the variable is under a square root sign. So if it's inside the square root, then it is not a polynomial. How about number 6? So it's not a polynomial because, as you can see, I think it's very obvious already based from the definition, the exponent must not be a negative. So thus, an algebraic expression is not a polynomial when the variable is in the denominator, when the variable is under a square root, and when the exponent of the variable is not a whole number. So let's proceed. So remember, we already discussed this. So the x squared here is one term, x squared plus 1 is two terms, x squared plus x squared plus 1 is three terms, and x squared plus xy minus y squared plus 1 has four terms. Because we can easily identify um, if one term is separated from another term by simply looking at the plus or minus sign. So for example, this one doesn't have a plus or minus. So meaning just one term. This is a plus, so first, second term. So two terms. There's a plus and a plus here. First term, second term, third term. So there are three terms all in all. There's a plus, a minus, and a plus here. First term, second term, third term, fourth term. There are four terms in total. So let's try to identify the number of terms in these expressions. So negative 3x to the power of 4y squared. So just one term. No plus, no minus. Here, 4x squared plus 5x minus 3. The answer is 3 terms. Because you have a plus and a minus. So first, second, third term. 1 half x cubed minus 1. Two terms because there's a minus. So first term, second term. Okay. Now, we've already discussed what are polynomials and there's a way for us to classify them. And the first possible way to classify polynomials would be through the number of terms. So the four different classifications would be monomial, binomial, trinomial, and multinomial. So I will give you time to observe how will we differentiate the four different classifications based from the examples that we have. Okay. If you notice, the number of terms here for monomial is just one. From the word itself, mono. So one. Bi, because there are two terms. Tri, because there are three terms. And finally, multinomial can be four or more. So that's multinomial. So let's try to identify the special name of the polynomial. So if it's just a 5, that's monomial. Okay, so it's just a constant term. So that's a monomial. How about number 2? 9a cubed minus 3a squared plus 2a minus 5. Here, our answer is multinomial because there are four terms. Number 3, x cubed plus x squared plus 1. So there's a plus. First, second, third term. three terms, so therefore, trinomial. Okay, number 4, 2/3 ab squared minus 8a squared b. So there's a minus, first term, second term. So two terms, binomial. So how about here? A plus b all over. Okay, we don't say again a plus b over 3 because if that's a plus b over 3, that would look like this one. So if we are referring that a plus b should have the denominator 3, both of them, you say all over. So a plus b all over 3, since you only have one fraction bar, so this is taken as one numerator, taken as one denominator. So we're just dealing with one fraction. So, monomial. So it doesn't mean that you're seeing two terms on the numerator, then it's binomial. You have to check that there's only one fraction in here. It's like saying, for example, if we have 5/3. So you can simply write it as 3 plus 2 all over 3. But still, originally, you only have one fraction at the first place. So, monomial. So here's the definition. Monomial has one term, binomial has two terms, trinomial has three terms, and multinomial has more than one term. But when we say binomial, but when we have two terms, we can call it as multinomial actually, but we better say binomial for it to be different from others. So commonly you will hear people saying that if there's four or more, that's multinomial. But still, binomial is a multinomial, trinomial is still a multinomial. But when it's four or more, there's no specific name. So commonly we will call it as multinomial instead. And if there's two, binomial because it has more specific name.